Okay, we are going to start again. So welcome to this last session of the morning. So now we have Steve Meyer, who is here to speak about building useful and usable web services. Steve is at the moment the technical project manager for the World Share platform at OCLC. So yeah, the floor is yours.
Thank you. So hello, I'm Steve. At OCLC, we really build a lot of APIs. And so I just wanted to sort of share some of our experiences. But first, I'd like to actually start with a quick poll. How many people here have used an API? And how many people here have built an API? Okay, a lot. That's good. And how many people just generally would have, a data source worth sharing externally? So we figured that a lot of people, a lot of libraries have information capable of being shared, and so we wanted to share some of our experiences because we've made APIs across a broad spectrum of failure to success. And we want to share some of these experiences because we think that, as people probably understand, they have great benefits for reusability and repurposing of both data and functionality. So this talk is about the flavor of APIs called web services. An API can mean a lot of things, from the specific bundle of code or a bundle of functionality in a code library to the API hooks into an operating system. But today I'm specifically talking about HTTP requests to remote systems. And so I'm primarily concerned with web resources in which the internet itself acts kind of like an operating system, in which you can send messages, send requests back and forth for data and for things to happen. And my specific focus is really about usability. So about a year and a half ago, I had the opportunity to attend the Business of APIs conference. And this is not really the library world, but the Fortune 500 world. The perspective is good, though, because when you abstract away the specifics in our data sets and our industries, the goal is the same, to let others innovate through your APIs to make your data and to make your services work harder. And so one of the best comments came from a presenter at ESPN who remarked that the primary job of designing an API is to mask your dirty laundry. He remarked that we all have legacy systems. And the point is a good one, and it gets better as you extrapolate it further. You can fret over the fact that you don't have a perfect data model, that you don't have perfect data on disk, and that your data is not perfectly modeled, or you can use an API to create an aspirational view of what your data looks like. So, despite the fact that internally you know that your software looks more like the car on the right, I think this is titled Acid-Washed Pinto, you can actually pretend that you're driving around something a little bit more classy to the outside world. And this is the usability of an API. Expose your data as you want it to look, irrespective of what it does look like on disk. And this is a point that can be easily lost today when a framework provides such easy mechanisms for serializing into machine-readable formats. Many applications begin with the scaffolding provided by a framework, but I would bet that most developers here who have worked with a mature production quality, say Ruby on Rails application, know that while maybe many of the controllers, the controller code stays very lean like it does when it was first scaffolded, a lot of the views, that changes a lot over time, because that really is the place where you have the tangible representation of your services, of your library, and of your data. And it is the direct reflection to your patrons. So this is really where the rubber hits the road. And your client developers really will judge you by how logical and usable your modeling is. So before I do that, I want to digress for a moment and go into a topic about standards versus making it up. Because even at OCLC, we tend to be all over the place on this, on when we craft an original API and when we implement something according to a standard. Now, first off, in our experience, this is flame war territory, and a full 30 minutes on the topic couldn't even do it justice. But basically, what I want to share is some of our pragmatic decision making for when we make this choice. We really think that you should evaluate this from the perspective of community base and agility. Standards should be used to bring a client understanding of your domain. We use standards when they're a good fit for the needs of an API, and the benefit of a good standard is that they bring with them a ready-made community that will understand your data model, your serializations, the kinds of requests that clients are going to want to make. And if you're lucky, that community will also produce a few code libraries. However, this community center metaphor is actually kind of apt because many standards tend to be underfunded. And I wish that this community center had its missing O. So, however, I also tend to believe that the source of something's greatest strengths are also the source of its greatest weakness. And this coin can have two sides to it. So standards are designed to serve, for example, every ILS, not just a single one. And this means that there are levels of abstraction and complexity that can be introduced into some of the most basic operations. Consider a minimally defined request for patron account data. Someone could implement something like this, that represents the HTTP request. Very simple, an identifier for the patron, an identifier for the class of data that you want to retrieve. As compared to, say, the full message that's required to be sent for an NSIP request, the Circulation Interchange Protocol standard. Also, a good standard is going to be very stable. If you implement it, you can rely on the fact that it will not change quickly. This means that it also will not be agile. What you find is that a standard then becomes a wrapper around some common or core functionality that similar systems are going to implement. In the case of our circulation APIs for some of our systems, we've elected to err on the side of community knowledge and stability, opting for an implementation of the NSIP standard for some of our services, in spite of its complexity. And that's because there really is a robust community built around ILS interoperability for circulation data. However, even within the same suite of software and services, we build other APIs from the ground up. NSIP is a standard that leverages HTTP for the transfer of messages back and forth. But the standard is very prescriptive in terms of what those messages contain. And what we're discovering is that for the machine-readable services that we want to create, often our data itself is the API. We're finding that more and more for the systems that we want to run, create to run the business of libraries, creating purchase orders, submitting payments to vendors, cataloging things, displaying item availability, a simple model of allowing clients to request and assert representations to manage applications is a very clean way of interacting with our systems. And so this model provides us with a framework for leveraging the most widely used standard around, which is HTTP itself. And so the astute among you will probably recognize that this is, what I'm describing is the REST, or the representational state transfer model of designing an API. Really, HTTP defines all the mechanisms needed to interact with a remote system. So consider a comparison maybe between HTTP and SQL. I bet that most of us here are familiar with some level of SQL and relational database-backed application development. And SQL is a standard that defines how to interact with a remote system. In effect, it defines an API. Now, an API implemented using REST principles and a close implementation of HTTP itself, you can do everything you can do in SQL, which includes a full life cycle of data management. So those of you who have worked with a SQL-based system are much closer to creating an API than you might realize. You know, to begin with, you can define a server space or a database. Both can define objects and entities and resources. The basic CRUD operations are supported in each of them. Each has a relatively natural way of expressing conditional querying. Each implements a client-based authentication and authorization model. And I don't mean to imply that there's a one-to-one comparison, because HTTP even goes further in some cases, such as defining a set of standardized error codes, whereas in the SQL side, the error codes that you're going to get back are going to be dependent on a specific relational database implementation. So at this point, without even necessarily going outside the realm of HTTP, as an API creator, we can use just about any respectable programming language and HTTP library and do all of the following, which is a pretty good set of building blocks for developing a system. And really all that we're kind of left with is, what do we want to say? Because HTTP itself has encapsulated sort of the common operations for communications. So I'll send you, on this particular topic, I'll simply leave you with this admonition. At OCLC, where we provide a lot of services through APIs to both members, member libraries, and to partners, we get about an equal amount of both complaints and advocacy for implementing a standard, as well as just cutting the leanest possible API that we could. There simply is no silver bullet when it comes to making this choice about implementing a specific standard or implementing a very lean API based on exposing a minimal amount of data. In both cases, you still have to either make a highly usable implementation of the standard or a highly usable local implementation. So the first usability-driven step that we try to make when we're crafting an API is to work on the modeling, and that's decomposing the content that makes up the catalog into its atomic parts. In this case, you want to think of the clients of your API are the chemists. The API is the set of available atomic materials, and your documentation is the periodic table of elements. And you should really focus on the modeling of your API for usability. Well-modeled objects are decomposed to the appropriate level for clarity and for reusability. And in a resource-oriented architecture, you really want to think well about choosing your objects wisely and naming them well. And if you get to be good at it, and you find yourself that you're making a lot of APIs, remember to consider consistency across your APIs. And that's one of those things that, for an organization as big as OCLC, we do definitely with mixed success. So let's start with decomposing objects and take the WorldCat metadata API as a case study. We started from a set of core principles for WorldCat itself. WorldCat is made up of of assets. They should have an intuitive API based on CRUD plus search. And really, we also want to avoid burdening external clients with our internal business logic. So there's the view at OCLC of what WorldCat is. And we basically do a lot, and we're trying to be responsible stewards of this data set that we're managing. And it's worth noting that even in this description of all the things that make up various pieces of WorldCat, I'm not even mentioning an actual implementation or technology stack yet. But in essence, this is our dirty laundry, and we don't go to work to show you this. Rather, using the principles that we've outlined, we're trying to present a rational view to the outside world of what WorldCat looks like through its APIs. And so what this means is that to create a new bibliographic record in WorldCat, we've employed a data modeling strategy that aims to keep clients unburdened by all of the highlighted items here. Instead, we can encapsulate all of these systems behind a single URL endpoint that represents the location to postmark data. So, seen another way, with a relatively small amount of code, we're able to give external access, and somewhat unprecedented access to write data into our core systems. Of course, as long as we're willing to accept a little bit of help from our friends. So one of the things that we tried to hide from clients is, and not burden them with, is, say, validation. And we have heard from from one of our colleagues out in the library industry, Terry Reese. He makes a free software tool called MarkEdit, and he was one of the first adopters of our API, and he said, I really would have preferred actually to have access to a validation endpoint so that I could make sure that that the data that I'm going to be sending you is accepted prior to sending it in for an update. And this is really part of the chemistry involved with making an API and striking this right molecular balance. So up to this point, I've talked about how to model and how to provide access. But next up, we always have to think about security in this context. So it is unrealistic to really think that all organizations can provide access to everybody to all their data. Data is governed by all sorts of rules and laws. In the U.S., we have rules governing personally identifiable information, rules protecting medical information, information protecting student data. And so for those reasons, when we're opening up our APIs externally, we have to think about the same kinds of authentication levels that we do in a user interface world. So many web services, we find that use a rather simplistic model of you're either all in or you're all out. Because it's just a simple IP address restriction that either gives you access to the API or that doesn't. And this model will work well when you're using APIs as an architectural strategy for internal reuse. But there are many other cases and many other interesting opportunities to let others interact with your data. And so you can consider all the different kinds of cases where you run the range from open access data to internal restrictions to I need to control access to the outside world, and I may need API key infrastructure. Keep in mind that when you're authenticating in a web service context, you're not authenticating a person, and so you want to avoid the temptation to make such an equivalence. The damage that can be done by machines to a data set is enormous. And consequently, when you are holding onto an API key or when you're issuing an API key, what you're doing is you're defining a mechanism for authenticating machine clients. And so this is a key that really only unlocks the door, but entrance into a place sometimes requires a little bit more authorization. And so that can be only part of the process. So consider what I need to do to get through customs. You might consider that my API key is kind of like my plane tickets, and it got me part of the way here. But as soon as I got inside, as soon as I landed, I still needed to establish my identity in such a way that I could be granted permission to enter the UK. And so this is a model that's becoming more common with APIs and accessing remote data through an open standard called OAuth. And so consider what is happening when you log into a site like Code Academy with, say, the options on the left, where you use a Facebook or a Google or a Twitter account to log in. You're essentially asking for a site like Google to authenticate a user for the purpose of granting a session token to a third party. And so once identity is established, now you can take advantage of, say, the roles and the permissions and granting them just as you would in a user interface application. And so, at OCLC, we are trying to provide API equivalents to a lot of the services that we provide in a user interface context. And so we have been working on our OAuth2 authorization server in which we could do this, so that we could enable someone to get through the front door of an acquisitions API. Once they're there, a certain identity securely, so that we know, yes, it may be external access, and I've authenticated the remote machine client, but now I know that it is maybe an acquisitions librarian from this institution who's trying to get access to the data and who has permission to do that. So we've chose OAuth because really it leverages HTTP mechanisms. It's sort of the most HTTP-ish of the API key systems you could use. It's a standard that's also used widely outside of library land. And it supports many different use cases. So we can choose, we have the flexibility to choose whether or not we just need to authenticate a remote system, or whether or not we need to go that extra step and also authenticate an individual at the same time. And this is a level of sophistication that requires a fairly deep infrastructure, but it does make for a well-designed authentication system in a web service context. So the other thing, when you're working with web services, just like in a user interface environment, you have to prepare for the unexpected. And so we consider this sage advice. This was a favorite quote of my old boss. And really, clients often make unexpected requests. Our software, we find, is never perfect, and our documentation is always written with our own biases. So the division I work at in OCLC used to be headed by a VP in Britain. And so this was circulated. It was a guide on BuzzFeed that went around the internet a little while ago, and it went around our offices. Someone actually did present to the big boss, this translation guide, and he replied, "Yep, that pretty much applies to me." And so that was actually either terrifying or a relief, depending on your experiences talking to him. But it makes for a good analogy here. We created our WorldCat Search API many years ago, and we had a feature that we implemented, holding availability. Our intent was that we really wanted to connect a patron to a library that holds an item in a machine-readable context, and let other applications do this. However, what we discovered was that what people actually wanted to do was read high-volume holdings data to do analysis. The problem here is that our system is not performant for that particular use case. Doing high-volume data transfers, you wouldn't necessarily do through an API that's designed for a one-at-a-time data record model. So this is one of these sort of unexpected things that we've learned, and it's meant that we found that the best thing to do is to start small with our APIs and plan to sort of deliver an initial set of core use cases and grow those use cases and let the API evolve. APIs do present a particular challenge in that machine clients react to change far worse than humans do. Breaking a client's XPath query, for example, will make your API seem rather flaky. So there's a real impact when you ask your users to change, because you're asking them to change their development cycle, not reorient their brain to a link that moved from left to right. So it's best to sort of use a model in which you start small and release early and often. And sometimes things just go wrong. In addition to the unintended use cases, we also experience a lot of cases where clients make mistakes. And this is one of those cases where it tends to be in large part due to our documentation and the things that we don't know that we're not explaining. So consider the complexity of your basic MARC record as a data structure and using it to interact with a remote system. From a usability perspective, we really need to strike a balance between two competing edicts. On the first hand, you cannot invalidate MARC. On the second hand, you must communicate clearly, and I would urge people to consider that the time when we need the clearest communication is under the worst circumstances, so when things are falling down. So in this case, what we had to do was design a system in which we could meet both of those requirements. So for example, we've decided to use, generally for our sort of REST-based APIs, we use an Atom pub model, where we use an Atom entry as the wrapper around the primary data that we're sending and receiving from clients. What this allows us to do is encapsulate the data. When someone sends a malformed request to one of our APIs, what we can do is send a response back in which we can echo what they sent us, because that's good practice. When something went wrong, we can say exactly what it is that they sent us so that we're all on the same page. But the Atom pub entry is a data model that's extensible, and so that we can add into it our own error conditions and our own error messaging. So these are some of the things that you really want to think about if you're designing an API. Not only what is it going to work like under successful conditions, but what does it mean for machines to behave in a manner in which things sometimes go wrong. And so, in conclusion, I'd just sort of like to leave you with this remark. And when you're doing API development, it's best to consider the principles of usability that you would, just in the same manner that you would in a user interface context, and just think about how those things translate into a machine world. So that's it.
Thank you very much, Steve, for the presentation. Do you have any question?
Steve, I would like to ask you the following question. To build good APIs, wouldn't it be good to use them yourself to build your own systems instead of on top of the systems you're providing?
Yes, that is definitely, so in my opinion, that is definitely the best way to build good APIs, because you work out the kinks faster than external clients do, because your use of them typically is not going to be that radically different from the way they do it. We don't always do that. A lot of times, the things that get in the way of doing that and convincing our engineers that we should be able to do that is the overhead, especially say of the API key system. We have performance SLAs that we really strive hard to meet, to make sure that we're delivering responses in sub-second times and whatnot. And so our engineers are always looking to shave every single possible transaction down to its leanest amount. And so, say an API key system, when we have the ability to do security through our own internal network and trust our firewall, that's one of those reasons why it makes a barrier. But as much as possible, we do try to use a lot of our APIs. We've actually got an API that we've recently created to do payments for interlibrary loan transactions. This was initially developed so that we could give some third-party partners who also serve the same libraries access to our billing infrastructure. And then what we're turning around and doing is we're making our own new version of our ILL user interface use the same web service and go through the same flow. So we're getting there, but we're not there yet.
Another question?
With machine-to-machine communications, one of the things that's often left out historically is what the client machine is able to do to the data. What are the best practices that you'd like to see in APIs for saying if the data is reshareable, open, public domain, etc.?
Okay, so for licensing, yeah. So a lot of the vast majority of no, I shouldn't say that. So many of the APIs that we work on are just operational data, such as creating purchase orders, looking up real-time status of something. And for those things, we don't think about that because it's really meant to be used in an in-memory kind of context. It's there, and as soon as the browser that's ultimately displaying it is done, it's gone. We have tried to sort of publish terms and conditions for our in the licensing for our data sets, but those typically happen outside of the APIs themselves. Now, in a linked data context, there are mechanisms to embed information or at least links to information with the rights in the data itself. But again, most of our APIs are not yet sort of working in a linked data model like that.
Another question? Well, I have a last question. You mentioned documentation.
Mm-hmm.
I know that for the service I'm working with, we developed the API, and then there was the question of the documentation. Who should write it? Because we were expecting the API to be used for various people, so probably technical people, but since we are also working with researchers, we thought maybe some people, more historians with some technological ability will use it as well. So we were wondering whether the technical person should write the documentation or maybe more a data person. Then there was a question of reviewing it for making the language better. So then we had an editorial person reviewing it, but at the end we ended up with something quite weird, which was not the perfect documentation. So yeah, I was wondering, what is your...
Yeah, so we know that we've got a lot of gaps in our documentation, and so one of the things that we're investigating is there's been a new sort of generation of tools that have cropped up around having the actual code that produces the API actually generate the public documentation. Sort of similar to the way that JavaDoc, you can publish API documentation like that, but more for sort of web service context. That's probably good for the highly technical programmers who are going to use the API and need to know just the ins and outs of what are the specific parameters I can send at this endpoint. But we find that we must have someone kind of more we have a technical product position that's sort of been developing, and we use people who are more from our product management side, who are a little bit closer to the customers, because we find that we definitely need to have someone use the API and describe it who doesn't know the internal systems. And that kind of goes to that point of you want to present that aspirational view of what your data can do, not so much what it looks like internally.
Thank you.